All right, today we are diving into a topic that honestly sounds like it's straight out of science fiction. But here's the thing, its consequences are incredibly real and, frankly, getting more urgent by the day. We're talking about the quantum revolution, a force that's going to bring unbelievable breakthroughs, but at the same time, it poses one of the single biggest security threats our digital world has ever faced.
This quote from the Boston Consulting Group just hits the nail on the head. I mean, think about it for a second. Every single thing we do online, our banking, our private messages, even our national secrets, it's all protected by digital locks. What we're talking about here is the very real possibility of a master key, a key that could open every single one of those locks all at once.
So you might be wondering, how is that even possible? Well, it all comes down to the basic building block of computing. The computers we use every day, they use bits. They're like simple light switches, either on or off, a 1 or a 0, that's it. The quantum computers, they use qubits. And thanks to this totally mind-bending idea called superposition, a qubit can be a 0, a 1, and both at the exact same time. This gives them the power to chew through millions of possibilities all at once instead of just one by one like our trusty old laptops.
And that incredible, almost unbelievable power is exactly what threatens to break everything. So let's get into it. Let's look at the actual mechanics of how a quantum computer could tear down the codes that hold our entire digital world together.
That master key we were talking about, it actually has a name, Shor's algorithm. Now, this is the specific weapon designed to crack the math behind our most common type of encryption. You know, the stuff for secure websites, digital signatures, RSA, ECC, that whole shebang. See, that encryption relies on a pretty clever trick. It's super easy to multiply two gigantic prime numbers together, but it's practically impossible for a normal computer to go backwards and figure out what those original two primes were. Well, for a powerful quantum computer running Shor's algorithm, that impossible math problem, it becomes child's play.
And this right here shows you the full picture of the attack. You've got Shor's algorithm on one side, just shattering those public key systems like RSA and ECC. But then there's another quantum tool, Grover's algorithm, that goes after a different kind of encryption called AES. That's the stuff we use to protect files and data just sitting on a hard drive. Now, it doesn't break it completely, but it weakens it so much that it basically cuts its security strength in half.
Okay, this is where it gets really chilling. Adversaries, right now, are already using a dead simple strategy. Harvest now, decrypt later. What does that mean? It means they are actively stealing and hoarding massive amounts of our encrypted data today. Think government secrets with a long shelf life, sensitive corporate R&D, even our private health records. They're just collecting it all and patiently waiting for the day they can switch on a quantum computer and unlock everything.
And please don't make the mistake of thinking this is some distant, far-off problem. A recent survey by Bain found that almost 3/4, 73%, of IT security pros believe quantum decryption will be a serious risk within just 5 years. The people on the front lines, the ones who live and breathe this stuff, they are sounding the alarm right now.
That sense of urgency is everything. Because this isn't just some abstract technical challenge anymore. It's a race against a very real ticking clock.
We actually have a deadline. Experts at BCG estimate that by 2035, that's just over a decade away, there's more than a 50-50 chance that a quantum computer capable of breaking our current encryption will be up and running.
And you know, that deadline gets even scarier when you look at history. See, major upgrades to our global cryptography aren't like flipping a switch. They take time, a lot of time. Past transitions like moving from DES to AES encryption took anywhere from 10 to 16 years to finish. The clock for this quantum transition is already ticking, and we just don't have that kind of time to spare.
And for businesses, the cost of just waiting around is staggering. Delaying this transition doesn't just put you at risk, it can literally double the cost. A planned, proactive migration that might cost a company, say $25 million today, could easily balloon into a $50 million hair-on-fire emergency scramble down the road.
So, that's the threat. It's huge, it's real, and it's coming. But the story absolutely does not end there. The good news is we are not sitting here defenseless. A massive, global effort is already underway to build the shield that's going to protect us.
The solution has a name, Post-Quantum Cryptography, or PQC for short. And this is key. We are not trying to make the old locks stronger. We're building entirely new kinds of locks.
Locks that are based on totally different mathematical problems that we believe are hard for both our normal computers and quantum computers to solve. And what's really cool is there isn't just one new lock. An agency in the US called NIST has been running this global competition to find the absolute best new algorithms, and they're standardizing a whole portfolio of them, with really promising ideas like lattice-based cryptography, which is kind of like hiding a secret in a super complex, multi-dimensional crystal structure. The goal is to have a diverse toolkit, so we're never again reliant on just one single point of failure.
So the tools are being built, the new locks are being forged, but are organizations actually ready to use them? Well, this data from Bain shows a huge disconnect. Even with this clear and approaching danger, a staggering 91% of tech leaders admit they have no plan, no roadmap at all to make this critical transition.
Look, getting started doesn't have to be this overwhelming, impossible task. The path forward is actually pretty logical. First, you do an inventory. You can't protect what you have if you don't even know where it is or what kind of locks are on it. Second, you assess your risk. Figure out which data is your crown jewels and prioritize protecting those doors first. And only then can you build a practical, step-by-step roadmap to make the switch before it becomes a crisis.
But you know, this whole story, it isn't just about stopping a threat, because preparing for the quantum era also means preparing ourselves for an incredible new frontier of possibilities.
It is so important to remember that the same incredible power that can break codes can also be used to build worlds. Quantum computing promises to help us design life-saving drugs at the molecular level, discover revolutionary new materials for things like clean energy, and solve logistical puzzles that are so complex they are literally impossible for today's computers to even attempt.
And this right here really captures that hopeful vision for the future. You have initiatives like the Open Quantum Institute at CERN, and they're working to make sure this technology serves the common good. Their entire mission is built around making it accessible to everyone, building global skills, and using diplomacy to guide this tech for the benefit of all humanity.
And that really brings us to our final, fundamental question. For decades, our entire digital world, every line of code, every security protocol, was built for just one kind of computer. The quantum era isn't going to replace that world, it's going to run right alongside it. It's creating a hybrid future. So the question we all have to ask ourselves is, are we really ready for the monumental task of rebuilding our world for two?